Hi everyone, it's Kira Garfolo here with Math 109 at Greenville Tech. I hope everyone is doing well, and today we will talk about section 1.3, which is focused on linear functions. So what exactly is a linear function? Well, in math, a linear function is any function that can be written in the following form. F of x, or y in many cases, equals ax plus b. In this case, a and b are both constants. So a is multiplied by x, and b is all on its own. Let's look at some examples. Our first example is x minus 3y equals 2. Is that linear or is it not? Well, first we need to see if we can put it into the form y equals ax plus b. We do a little bit of algebra and we solve for y, we end up with y equals 1/3 times x minus 2/3. So yes, that does go into that format. Here, ax is equal to 1/3 x. So a would be 1/3. And 2/3 is off by itself as a constant, so it would be b. This is a linear function. Now, what do we have if xy equals 5? Solving for y here, we get y equals 5 divided by x. There's no way to write this as a times x plus b or even plus 0 without a b. There's no way to put a coefficient out in front of a linear term x. So no, this is not linear. What about y equals -4? This one is tricky a little bit, for a minute at least, because there isn't an x term. But what if we let ax be 0? So a would be 0, so there wouldn't be an x. And then -4 would be b. That's exactly what we have. It is indeed a linear function that we could write as 0x minus 4. Remember that 0 times anything is 0, and often it's just omitted when we write the function. What about x equals 2? Is that going to be linear? No, because we can't solve for y, because there's no y. Remember, y is by itself. It doesn't have a coefficient in front of it. So if we can't solve for y, and there's no y in the equation to begin with, then it's not a function. It's not a linear function for y. Now, when we have any function, we can talk about its intercepts. And an intercept is just a fancy word to say it's the points where the graphs touch an axis. So if it's touching the x-axis, remember that x is the horizontal axis, then we say it's an x-intercept. If it touches the vertical y-axis, it's a y-intercept. So it's an intercept of wherever it touches that axis. If we look here, we can see that the graph touches the x-axis somewhere around -2. And it touches the y-axis somewhere around 4. But remember that we need to give full coordinates in most cases for a point. So we would have an x-intercept of -2, 0, and a y-intercept of 0, 4. An x-intercept will always have y equals 0, and a y-intercept will always have x equals 0. Now, we can find our intercepts in a few different ways. We can find intercepts algebraically for any function, if it's in y equals or f of x equals or g of t equals or however it's written. To find, the y-intercept, we need to set x equals to 0, because remember, x equals 0 when it's on that vertical axis. Any function is only going to have one single y-intercept. Take a minute and think about why that might be true. Did you figure it out? It's only going to have one single y-intercept because remember that a function must pass the vertical line test. The y-axis is a vertical line. So we can't have multiple points on that same vertical line. It just doesn't work. So when you're solving for intercepts here, remember that you can only have one single y-intercept. If you find more than one, you should probably find your mistake. Now, if we want to find the x-intercepts, we're going to set y equals to 0 and solve for x. If we're dealing with a linear function, we're only going to have one intercept, okay? That is because linear functions are straight lines. They look linear, has the word line in it. So it's not curving around. So once it crosses it, it can't come back up or back down, depending which way the graph is pointing, to touch it again. So if you're dealing with linear functions, you only have one x and one y intercept. Now, the only exception to these rules are horizontal lines. And horizontal line, as we'll see at the end of today or at the end of one of the lessons coming up, horizontal lines are constant functions. And a constant function means that it's a straight line going across horizontally. It doesn't go up, it doesn't go down. That will always have a single y-intercept, okay? Unless, well, no, it'll always have a single y-intercept. But, and if it's a vertical line, it's not a function. And horizontal lines will only have 0 or infinitely many x-intercepts. Unless it is along that x-axis, it's not going to have any x-intercept because it's not going up and it's not going down. So it can't ever touch it. Think about that. If you draw a horizontal line, you can't ever get to that axis unless you draw it directly on that axis. And in that case, every point on that axis is an intercept. So that is the only exception here. If you're dealing with a standard, I'd say just like a run-of-the-mill linear equation, you'll have one x-intercept and one y-intercept. Let's look at an example. We want to find our intercepts algebraically. So we have the function 3x minus 4y equals 24. Now remember, when we're solving for the y-intercept, we're solving for y. So leave y alone, but make x equal 0. So when we do that, we'll have 3 times 0 minus 4y equals 24. 3 times 0 goes away because it's 0. And so we're left with negative 4y equals 24. And remember back from your last math class, or maybe before that, to get rid of that negative 4, you're going to divide both sides, and you'll end up with y equals negative 6. So the y-intercept occurs at y equals negative 6. If we want to write that in terms of coordinates, remember that the y-intercept always has x equals 0. So you'll just write it as 0, negative 6. Excuse me, I'm losing my voice after all my teaching today. Now, for the x-intercept, we do the backwards. X-intercept, you're solving for x. So you'll leave x alone, but you're going to make y equal to 0. In this example, we'll have 3 times x minus 4 times 0 equals 24. That 4 times 0 goes away, so we're left with just 3x times equals 24, which gives us x equals 8 if we divide both sides by 3. Now, if we want to write this in coordinates, remember that y by definition equals 0, and x we've already just solved equals 8. So the coordinates will be 8, 0. Now, I know everyone also wants to use their graphing calculators, and we can find intercepts graphically. It's easy enough to do simple examples with algebra, right? But sometimes we really like to use our calculators. So the first thing you're going to do, I'm going to walk you through these steps, and then we're going to do an example, and I'll show you exactly how it works. The first thing you're going to do is start by graphing the function in the calculator. So remember that we go to the y equals and we graph it. For our x-intercept, there's a nice feature that solves it for us. It's called the 0 feature. If we're in the graph, you can go to Second, Calc, and you'll select 0. You want to use the arrows on either side to tell it where the left side is, where the right side is, and you'll press enter and it'll solve it for you. And then for the y-intercept, we're going to use the trace feature. We can type 0 to set x equals a 0, and it'll spit our answer out right for us. Now, I realize that probably doesn't make much sense at all, just written like that, but let's follow along with an example. Our example has Bob moving boxes from his old apartment to a new apartment. He has 50 boxes sitting in his living room ready to move, and he can only fit 5 boxes in his car at a time. The number of boxes remaining at his old apartment is y equals -5 times x plus 50, where x is the number of carloads Bob has moved. And now we want to find the intercepts and talk about what they actually mean in terms of Bob's situation. Let's find our intercepts with our calculator. Give me one moment. Okay. So we have, let me clear out my y equals. Let me clear out my stat plot. This is always a fun activity. If remember that if you have a scatter plot on, you're going to probably want to turn it off when you're dealing with your functions. So there we go. Everything is cleared now. Now, if we think back to Bob, Bob's equation was y equals -5x plus 50. So we'll go into y equals, and we want to say -5x plus 50. I want to make sure I'm in the standard zoom still. And I'm going to graph that. Now we see here that we don't get that much useful information, right? We're talking about 50 boxes. So we probably want to change our window a little bit. You can do some exploration to see where you need it to be. But I'm going to change our maximum on the x to go to 15. And I'm going to change our y maximum to go to 60. Now when I graph it, I get the complete graph. Now I've done this problem before, so I made a good guess for my first one, but don't fret if you don't make it on the first one. Sometimes it takes changing the window a few times to figure out exactly where you need to be. Okay, so let's find our x-intercept first. If we press the second button, and the trace button has this blue calc over it, so we click that, it's going to give us some options for calculating. A 0 is just a fancy word for saying where it crosses the x-intercept, or where the x-axis. So a 0 is an x-intercept. So let's choose 0. What you want to do, if you look there at the bottom down here, it's asking you for the left bound. That means that you want to use your arrows and trace along the graph to get kind of close to that 0, but really anywhere on the left side of that 0 is fine. So you want to be on the left side of where it crosses that axis and press enter. Now it's going to say, okay, well, what about the right bound? So now you use your arrow to go to the other side. And once you're on the other side of that intercept, you're going to press enter. Now it's going to come up one more time. It's going to show you those arrows of where it's lining up. And it's going to say, hey, guess. And you say, sure, press enter one more time. And it tells you here that your 0 is x equals -10. And remember, y equals 0 by definition. So we know that our x-intercept is at 10. The coordinates, as shown here, are 10, 0. Now, while we're on the graphing screen, why don't we go ahead and find our y-intercept? The best way to find the y-intercept is going to be use the trace. Remember, you can move all over using those arrow buttons with the trace. But you can also skip around with trace. It doesn't look like it, but if you just simply type a value in, it's going to input it for x. So here I'm just going to say, hey, 0. I say, okay, well, x equals 0. And when I press enter, it's going to give me the axis. It's going to tell me exactly what it's at. So when x equals 0, y equals 50. That is the coordinates of our y-intercept. So 0, 50. Let's go back over here to our presentation and take a look. As we found, our y-intercept was 0, 50. We're going to think about that. What does that mean for Bob? This tells us that when x equals 0, so when he's made 0 trips, remember, x is the number of trips he's made. So when he's made 0 trips, he has 50 boxes remaining at his old apartment, which makes sense. He packed them into 50 boxes and he hasn't taken any of them out yet. The x-intercept is where y equals 0. So y is the number of boxes remaining. If y equals 0, then there are no boxes remaining. So the x-intercept being 10, 0 tells us that, hey, after 10 trips, there are 0 boxes remaining. So he's going to need 10 trips to clear out his apartment. We've talked about how linear functions are straight lines. And straight lines are defined by something called slope. Slope has a symbol of m in math. And all it is the steepness of the line. It's how much it slants up or slants down or doesn't slant at all. There are several equivalent calculations, some of which you've maybe heard before. It can be the vertical change over the horizontal change. It can be rise over run. Or if you have 2 points, it's often easiest to use the actual formula, y2 minus y1 over x2 minus x1. Be careful with your order of operations, especially if you're using a calculator. Make sure you put it in parentheses and use what makes sense to you. I go back and forth between rise over run and the actual coordinate points. It just depends what I have. Remember that rise is that vertical change and run is that horizontal change. Let's look at some examples. First, let's calculate the slope of the line that goes through 2, 7 and 5, 3. Now, technically, you should use, according to the formula, y2 minus y1 means use the second y first and then the first y. Truth be told, it doesn't matter what order you do them in, as long as y is on top and you always do it in the same order. So here, using the formula, we would have 3 minus 7 on top and 5 minus 2 on the bottom. And when we solve that, we'll have negative 4 over 3. Now, if you're curious, remember it doesn't matter what order we do it in. We could have done 7 minus 3 on the top to get a positive 4 on the top, but that would mean that we'd have a 2 minus 5 to get a negative 3 on the bottom. You're welcome to use the first minus the second, but again, make sure that you always do it in the same order and make sure that the y changes on top with the x change on the bottom. What about this example? ADA guidelines require that every 1 inch of vertical rise requires at least 1 foot of ramp length. So you need 1 foot of your ramp to go up 1 inch. What is the maximum slope of this ramp? So we already know that it can only go up 1 inch. We're going over 1 foot. So rise over run is 1 inch over 1 foot. But be careful here. We have to read carefully. Our slope is not just 1 over 1 because we're talking about inches and then we're talking about feet. So it's easiest to put everything into inches. 1 foot is 12 inches. So you can go up 1 inch, there's your rise, over run 12 inches. So your maximum slope is that 1 over 12. Now let's talk about the relationship between a line and its slope. A positive slope has the line pointing upwards. As you move up on the x-axis, so you move to the right, that's increasing x, then your graph is also going up vertically. So as you move increasing on the x-axis, you're increasing on the y-axis. Your rise and your run are both positive as you move in that positive direction. The opposite is a negative slope. In that case, the line falls. As you increase your x, your y is actually falling. A slope equals 0 is a special case. That is that horizontal line that we saw at the very beginning when we were talking about our examples. It is a linear function. Notice here that in this example, there is no x-intercept because it's a straight line across and it's well above the x-axis and it'll never touch and never cross that. It does have a y-intercept, however. Now, undefined slope is when you have a denominator equals 0. So you can have whatever you want for your rise, but your run is 0. If your x doesn't change, then you end up with a 0 denominator, thus giving the term an undefined slope. Any truly vertical line has an undefined slope. Now we can make our lives easier by learning about slope-intercept form when we're writing lines. If we write our linear function in the form y equals mx plus b, we can straight away tell you the slope and we can straight away tell you the y-intercept. M is the slope as usual, and b is going to tell us our y-intercept. The coordinates of the y-intercept will be 0, b. Let's look at an example. For our first one, we have y equals 4x plus 1. Here, remember mx plus b, so m is 4. So our slope is simply 4. Plus 1, that constant term, the value of b is 1. So our y-intercept is 0, 1. The y-intercept is at a height of 1. Now the next example, we have 6x plus 3y equals 2. To quickly tell the slope and y-intercept of this, we first need to use a little bit of algebra to put it into slope-intercept form. Solving for y is all we need to do to put it in slope-intercept form. That's all you're doing when you're asked to transfer this to slope-intercept. Just solve for y. When we do that, we get y equals negative 2x plus 2/3. Take a minute on your own and make sure you can solve that and make it look the same. It's a good algebra practice. Looking here, negative 2x plus 2/3, mx plus b. So here, m is going to be negative 2. So our slope is negative 2. And b is 2/3 because plus b is 2/3. Our y-intercept then is 0b, which is 0 2/3. Be careful here. We see the slope has a negative 2, so it's a negative slope. It will look downwards if you graph it. Be careful with your signs for the intercept too. Remember, mx plus b is slope-intercept form. If we have a minus something, then our b has to be negative, and thus our intercept will be negative. Just something to watch out for. It's really easy to lose negatives. Let's go back to Bob and his moving situation. Remember that we had the formula y equals negative 5x plus 50. This is already in slope-intercept form. Our slope is going to be negative 5. This tells us that for every trip, so every one increase in x, we are going to decrease the number of boxes by 5. Okay, our rate of change, which is just another way to say slope, is negative 5 per trip. The y-intercept, or b in this, is 50. So that tells us that when we had 0 trips, we started with 50 boxes. We talked a little bit about that on the previous slide, but now looking at it from slope-intercept form, we're going to revisit it again. Now, there are some special applications of linear functions that we can talk about, especially if you're interested in business or you're majoring in something that's going to require you to take some economics or some business classes. This will be useful to you. We can relate profit, revenue, and cost using the equation profit equals revenue minus cost. Now, looking at the screen, I know you see P of X equals R of X minus C of X, but really we're just representing profit equals revenue minus cost. Now take a minute and take your math hat off and think about what that means. You already know this. how much money do you make off of something? Well, whatever you sold it for minus whatever it costs to make it. So if you're making cookies, then if it costs you for every cookie that you sell for $5, costs you $2 to make, then you're only going to make 5 minus 2, $3 per cookie. Now the X represents how many units you have, okay? So that's going to tell you per cookie. Let's think about an example. You're making tables. The cost and revenue per table, the cost is 300X plus 5,000. So that means for every one table, you're going to spend $300 in materials and labor, plus you have $5,000 of fixed costs. So fixed, overhead costs, whatever. Even if you make no tables, you're going to be paying $5,000 in costs. If you're not a business person, don't get too bogged down what that could mean. Assume that's your rent. It's going to cost you $5,000 to pay your rent for the warehouse. And then for every table that you make, you have to pay $300 in wood. Then R of X is 500X. So that's saying, okay, you're going to sell every table for $500. That's what you'll bring in for every table. If we want to write this in the profit function that we just talked about, then we say, okay, remember all it is R of X minus C of X. So it's going to be 500X minus that quantity of 300X plus 5,000. Now this is one other place to be careful with. It's not complex math, but make sure you use parentheses around that cost function and make sure you distribute the negative. Here we would end up with 200X minus 5,000. So what do we even do with this? Well, there's a lot you can do this in the business setting, but perhaps if you're just an amateur, woodworking and want to see, okay, well, how much do I have to sell to even make this worth my time? One of the first things you're going to want to look at is how many you need to sell to break even. So remember that we have P of X equals 200X minus 5,000. If we break even, we make zero profit. We don't lose any money, but we don't gain any money. So all we need to do is set this equal to 0. So we get 0 equals 200X minus 5,000. Bringing that 5,000 to the other side, we get 5,000 equals 200X. Then using some basic algebra to get X on its own, we see that 25 equals X. You would need to sell 25 tables to break even. Seems like a lot of tables for an amateur woodworker. I hope it's not an amateur case. Now, as I mentioned, there are a couple special linear functions. Just want to talk about them and make you aware of them. The constant function is just that horizontal line that we talked about at the start of class. Remember, it's y equals 0x plus b because a horizontal line has 0 slope. And so simply, it comes out to be y equals b. So no matter what x is, y is that same value of b. It is a horizontal line. The identity function, on the other hand, is just y equals x. So there's no intercept that, well, the intercept is the origin. There's no non-zero value of your intercept. So it goes straight through that 0, 0 origin. And at every point, y equals x. We call that the identity function. We use it a lot in other classes, not a ton in this one, but it does come up, especially in your textbook on occasion. So definitely be familiar with it. Okay, that is the end of our slides. So if you have any additional questions, remember to reference your weekly checklist and also to reference the Blackboard resources that are available for our course in the shell. As always, if you have other questions, remember to use the Math Center, and remember you can email me or stop by my office hours at any time.